Okay, 3.2 is inverse functions. Woo! Inverse means like the opposite, right? So when I think of inverse, I think about the opposite of something. So we are going to be working on the opposite of a function. So we're going to change a function around, and we're going to work on finding the opposite of it. Remember, we have talked about what a one-to-one function is. Does anybody remember what a one-to-one function is?
With no x or y variable.
Excellent. So a one-to-one function means a function, and I'm going to abbreviate function fx, and yes, I realize there is no x in the word function.
Close enough.
Just go with me here. Okay, so a one-to-one function is a function that has what we call unique, which means it doesn't repeat, x and y values. A function that has unique and x and y values. So neither x nor y repeats. We talked yesterday about the vertical line test. We said a relation was a function if it passed the vertical line test. So today we're going to introduce the horizontal line test, which is the almost exact same thing, except instead of drawing a vertical line, I'm going to draw a horizontal line. So the horizontal line test determines if a function is 1 to 1. So the horizontal line test determines if a function is 1 to 1. An example of that would be a parabola. You would agree that, oh, sorry, you can't really see it on the board. Let me draw it somewhere else.
1 to 1.
If I have a parabola, you'd agree that it's going to pass the vertical line test, right? It's only touching one time every time it does the vertical line. So it is a function, all right? But if I do a horizontal line, how many times is it touching? Twice. So it is a function, but it's not 1 to 1, which means its x and y values are not unique. Something is repeating there. Okay, so the y values are going to repeat. An inverse function is a function that is reflected across the line y equals x. The inverse function is a function that is reflected across the line y equals x from its original. And we use f to the -1 power to represent inverse. So this is the symbol for inverse. Now, when you tell me f -1, I don't want you to say f -1. I want you to say f inverse. Okay? And inverse, that -1 is a little exponent. Invertible just means that a function does have an inverse. That's what invertible means, that a function does have an inverse. You all right over there? Okay. Okay. Seriously.
Sorry. I didn't sleep well.
Okay. The inverse of a function. So let's talk about how we find the inverse of a function. The first type of inverse that we're going to find is going to deal with ordered pairs. So this is an easy way to start. Ordered pairs Determine if the ordered pairs are 1 to 1, and if they are 1 to 1, then we're going to find the inverse. So let's look at this example that we have in just a minute. Okay, first of all, is number 1 1 to 1? Meaning, do you have unique x and y values? Yes. Okay. So in order to find the inverse, all you're going to do is switch your x and y around.
I was right.
Okay, so to find the inverse of this function, we'll call this f inverse. The first ordered pair would just be 1, 2. The second ordered pair would be 3, 4. Sorry, thank you. 4, 3.
And 0, 4.
And 0, 4. You don't need to draw this, but I want to show you something. 2, 1 is here. 3, 4 is here. 4, 0 is here. So the red dots, you don't need to draw this, I want you just to watch. The red dots represent the original function. The blue dots, if I do 1, 2, and then 4, 3, and then 0, 4. What this is saying is the line y equals x goes like this. And do you see, let's look at the red and blue dots. Do you see how they are opposite of each other? So let me get a different color for us to look at.
Can you actually graph them? I just see a bunch of dots.
Yeah, well that's because they're points, right? So can you actually graph the lines? Is that what you're saying?
Yes.
Yes, and we will. Yeah. So do you see how that these two right here are opposite? They're just across this line from each other. And these two are just across the line from each other. And these two are the same distance away from this line as each other. You guys see that? They are opposites of each other. So they are inverses of each other. Okay? So let's look at example 2. Is example 2 a 1 to 1 function? Why not, Tish?
Because you got your y's that repeat. Your two.
These two y's are repeating, right? So if the function is not 1 to 1, it does not have an inverse. So we cannot find the inverse here. So we will write not, can you guys see that? Or is it too lime greeny?
It's 2 lime green.
Yeah, I just made that up. It is not invertible, which means there is no inverse here. So we found the inverse of ordered pairs. So now we're going to find the inverse of an equation. So that's your blank there. Or you can write function. The inverse of a function. There are 2 different methods to finding the inverse of an equation, but both will work for you. You can choose whichever method you like better. So we're going to do a problem where we reverse it, and then we're going to do the switch and solve. It really is the same thing. But students like to look at it differently, and that's fine, whichever one works for your brain. I don't care. All right? So reverse the equation. The first thing to do to find the inverse, okay, is we're going to substitute, instead of f of x, we know that this is really a y, right? You guys agree with that? Instead of the x, we know this is really a y. So step number 1 is to switch x and y. So I'm going to make this x equals 5y plus 1. If I'm reversing the equation, that means I'm doing reverse PEMDAS. Okay, so I'm starting down at the adding and subtracting, and I'm going in reverse. So if we look at this equation, is there anything that's being added or subtracted? Don't think too hard.
1.
The 1. is being added, right? So if we're starting in reverse PEMDAS, that means we're starting down here with the adding and subtracting. Justin, can you get the door, please? Okay, so what we're going to do is we're going to take the 1 and we're going to subtract 1 over. So we are reversing the equation. You can come get some notes up here. So this becomes x minus 1 equals 5y. What's the next thing we have to reverse if we're going to reverse PEMDAS? We've already taken care of addition and subtraction. Multiplication and division. Is there a multiplication happening here? The 5 and the y are being multiplied, right? So the opposite of that is going to be to divide by 5. So I get y to be x minus 1 over 5. The goal is to always get y by itself. Okay, so now that y is by itself, I can substitute in my f inverse of x. Because we started with f of x, right? In the very beginning we started with f of x. So now we flip the equation around, we've reversed it. So now we're going to say, now this is the inverse equation. It doesn't matter which side f inverse of x is on. It can be on either side. X minus 1 over 5 is going to be our final answer. What's that look for? Ask your question.
No, I'm good. I'm trying to figure it out.
Ask your question. Where did I get what from?
No, I figured it out. You plug it in for y, figure it out.
Yes, we just substituted that. We took the y out, and we just put in f inverse of x. Okay, because once y is by itself, then we need to replace it with inverse. Okay, so that's the first way, is to do reverse PEMDAS. The second way, we're going to start it the same way. We're going to switch. We know that this is really y. So we're going to switch x and y. It doesn't matter that it says g of x. That still means the same thing.
Throwing us off.
My what?
They're trying to throw us off.
Yeah, they are trying to throw you off. But it's the same thing. It just means the same thing. So we have x equals 3y cubed minus 7. Notice I left the 3 and I left the cube. Right? I didn't do anything different. I just simply swapped x and y. So the switch and solve method just says switch x and y and then solve for y. But solving for y means you have to do reverse PEMDAS. So again, this is really the exact same process. Students just like to think of it differently. So if I'm going to solve this for y, you guys are used to solving for y when you try to get y equals mx plus b, right? Do you guys remember doing that a long time ago? Like eons ago, right?
Yes.
Trying to do y equals mx plus b. So we're going to get y by itself. So what's the first thing I need to do to get y by itself? Add 7. Okay? So we're going to add 7 over to the other side. Go ahead and do that. Okay, the next thing I need to do to get y by itself is either divide by 3 or get rid of that cube.
Cube root.
When you don't know what to do, this is when reverse PEMDAS does come in handy. We just took care of addition and subtraction. What comes after addition and subtraction if we're going in reverse order? Multiplication and division. So we need to get rid of the 3 by dividing by 3. We will leave the cube, which is an exponent, till the end. So I have x plus 7 over 3 equals y cubed. Bless you. Does anyone know how we get rid of that cube?
Cube root.
Not multiply by 3. How would we get rid of a square? Not divide. Exponents are not the same as division. No. No.
No, we're square.
Look, if you had an x squared, how do you get rid of that square? Do you guys remember? Square root it. Right? That's how you get rid of x squared. So to get rid of a cube,
Cube root.
cube root it.
It's called the cube root.
It is called the cube root. all that means is, listen, whatever the power is, that's the root you take it to, right? That's the number you put outside the little box. So if it's a cube, you're going to take the cube root. If it's a fifth, you'll take the fifth root. Okay, to get rid of an exponent, you take the root. Taking the root is that little symbol, that check mark symbol. Okay, but whatever you do to one side, you have to. This entire fraction needs to be underneath my cube root sign. Okay, the entire fraction needs to be under the cube root. That looks really scary, but it's not. The cube and the cube root cancel out. So I just have y equals the cube root of x plus 7 over 3 I can't simplify that. All right, I'm not going to ask you to find the cube root of x plus 7 over 3. But what do we do now that y is by itself? What do we have to switch it back to? F what? F inverse, right? That little f negative 1 thing. So this y becomes f, except what letter did they use?
G.
They use G, right? So we'll write G inverse of x, just because they use G in the beginning, equals the cube root of x plus 7 over 3. So the whole time we're doing this, we're doing reverse PEMDAS, or solving for y, whichever way you'd like to look at it. Darius?
Why do you write it backwards? Why don't you write G?
It doesn't matter which way you write it, right? Because would you agree that 2 plus 3 is 5, right? And 5 is 2 plus 3? So it doesn't matter which way you write it. I know like in Algebra 1 they teach you to always write the variable first, but we know it means the same thing, so it doesn't matter which way you write it. Okay. Any questions on that? Okay, I think we have another example. Yeah? Oh, yes, we have plenty more examples. Perfect! Cynthia just rolled her eyes at me and gave me a big sigh. Are you all right, Cynthia? Ready for the day to be over? I think you are speaking for your classmates. Okay. So, again, first step, if you're a step person, is to switch x and y. The first step is to switch x and y. Okay, so I know that this is really my y, so I'm going to swap them out. So I have x equals the cube root of y minus 9. Now you can either do reverse PEMDAS, or you can solve for y, whichever one you would like to do. But here's the problem. If I'm doing reverse PEMDAS, it says addition and subtraction first, and I need to get rid of that 9, right, because it's being subtracted. The problem is that whole y minus 9 is trapped underneath the cube root. I can't do anything with it until I get rid of that cube root. So just like we got rid of a cube by taking the cube root, I'm going to get rid of a cube root by taking it to the third power. They're opposite operations of each other. Okay, so I'm going to raise this entire side to the third power. And I know to do that because roots and powers are opposite operations of each other. So these cancel each other out on this side. But in algebra, whatever you do to one side, you have to. So if I cubed one side, that means I need to cube the other side. So I'm just going to cube the x. Can we do anything with x cubed? No, it just becomes x cubed equals y minus 9. Now it's a pretty simple problem. What should we do next, Amanda?
Add 9.
Perfect. Add 9 over.
Isn't then like y minus 9 in parentheses though?
It can be, but it's going to be the same thing if you have it in parentheses or not. Because there's nothing
Parentheses last,
there, right, but there's nothing, you can't do anything more to it. And what are you going to do to that if it's y minus 9, right? There isn't anything to do.
Like,
So
that's what I'm saying.
it can be kind of confusing. The parentheses are there kind of as an extra thing, so we don't really need them. So now that y is by itself, what do? Inverse, right? And what letter? They gave us F, so that means we're going to do, I'm just going to erase mine. Feel free to do the same. F inverse of x. So when you know that y is completely by itself, then you can put in F inverse of x. So step number 2, whether you want to put reverse PEMDAS or you want to solve for y, whichever one you like better. Okay, that's step number 2. So looking at example 2, again, the first thing to do, we know that this is really y, so I'm going to switch them out. So I have x equals negative 1/2 y to the 4th plus 4. Crystal, what's going to be the first thing you're going to do? Good. Subtract 4 to either side. Okay? So let's go ahead and subtract 4 to either side. Elena, are we going to get rid of that negative 1/2 or are we going to get rid of the 4th first?
Negative 1/2.
Why?
Because this reverse PEMDAS and you do the exponents. Well, not last, but after that.
Okay. Did you hear what Elena said? We already took care of addition and subtraction. Next comes multiplication and division, and that 1/2 is being multiplied. How do we get rid of negative 1/2? Multiply by the reciprocal, which would be negative 2 over 1. That cancels. Okay, so I'm taking you back to Algebra 1. To get rid of a fraction that's being multiplied, you have to multiply by the reciprocal. So on the right side of the problem, I'm left with y to the 4th. And on the left side of the problem, I have to multiply this whole thing. Isn't negative 2 over 1 the same thing as just negative 2? Would you guys agree with that? Yeah. Okay. So I have a negative 2 times that entire thing. So let's go ahead and multiply the negative 2 through. Let's distribute the negative 2 through. So I have negative 2x plus 8. Are we okay so far? Anybody have questions? Let me know. It's kind of tricky. Paula, what's the last thing we're going to do? How do we get rid of that 4th? The root, right? So we're going to do the root, and we just put a 4 on the outside of the root because it's a 4th power, so it becomes 4th root. And so we're going to do 4th root of the other entire side of it. That makes my 4 gone. The only thing I have left is y. But instead of y, what do we write, Tracy? But not g minus 1, it's called what? G inverse. There you go. G inverse of x equals the 4th root of negative 2x plus 8. Does anyone have any questions with that? Okay, and we're going to start number 3 together, and then I want you to finish it. On number 3, after you switch x and y, what should you get rid of first on number 3? What do you think you should get rid of first on number 3? What's trapping the entire problem?
The division.
The division 6, right? That 6 is trapping the whole problem. And if 6 is being divided, how do I get rid of it? Multiply. So you're going to multiply both sides by 6. That's going to be your first step after you switch x and y. So I want you to go ahead and get started. I'm going to move this screen and start on it too. But I want you to try to do it on your own. What's your question?
Are you supposed to divide multiply the whole problem or just the x?
The only part of the problem on the left, you mean on the right side or the left side?
Both.
Okay, so when I multiply on the right side, I have 6 over 1, right? But these 6's cancel each other out. So I can't distribute it anywhere because it's gone. Then on the left side, the only thing to multiply it by is just the x, right? What are you doing next, Patrick? You going to divide by 3 or are you going to square?
Divide by 3.
Okay, I would agree with that. Divide by 3. Okay. What do we put on the outside instead? F inverse of x. Raise your hand if this is what you have. The square root of x, 6x plus 5 over 3. Excellent. Does anyone have questions on this one, how we got anything? Now, I will show you, look up here for just a second. You can reduce 6 over 3. What is 6 over 3 reduced to? 2. So you could make this the square root of 2x plus 5/3, because 5 over 3 doesn't reduce, right? So you could make it look like that, but I'm okay with you leaving it as the one that's in the black box. Okay.
But if this was on like the ECA,
It's not on the
if
ECA.
it was,
Okay. I don't know how to answer that because I've never seen. I mean, hypothetically, I've never seen this on the ECA. This is an Algebra 2 standard.
I thought you could divide the 3 into 6x because that's just a 3. It doesn't have an x.
Right, but can you
And
do?
that's 6x.
You could do 6x over 3, and you could do 6 times x over 3 times 1, and cancel out those out, right? And you still would have 2x over 1.
Yeah, true.
You can still do that,
Yeah.
yep. Okay. All right, why don't you try number 4 on your own? The question was, if this happened to show up on the ECA, would they want you to reduce it or not?
yes, all the way down.
This would most likely be a multiple choice question because it would be really hard to type in the square root of something on the keyboard. So, right, so my guess would be they would not have both answers, I don't think, on the ECA question test, if this was on the ECA. What are we getting rid of first on this problem?
I'm on a whole different.
We need to get rid of that 3 first, right? Because the 3 is holding the radical tight. I can't do anything with the radical until I get rid of that 3. The 3 is being multiplied, so how do I get rid of it? Okay, so I'm going to divide both sides by 3. Okay, keep going. What do we do with that 7? Subtract it. So I have x over 3 squared minus 7, which means y is by itself now. And if y is by itself, now we can replace it and write, this one has an h.
Inverse of x.
So h inverse of x. Anyone else get this answer? A few of you? There's a lot going on. Let me erase some stuff. It's kind of hard to see.
There we go.
Okay, so I squared, and I don't really want to simplify x over 3 because there are going to be times, let me show you this real quick. There are going to be times when you have to square in your homework today, where when you square the other side, it looks like this. And if you were to square that, it'd be x squared plus 6x plus 9. You'd have to do the box and FOIL it. So you can just leave it as x plus 3 over squared if that was an example that you had. You don't need to multiply it out. Any questions on example 4? Okay, lastly, graphing inverse functions. So you have 2 in your homework that you need to graph, but they are not ridiculous problems. So let's go over how we would work on that. So your blank there says graphing inverse functions. The inverse of a one-to-one function contains exactly the same ordered pairs as the function, so like I showed you on that graph, except that the coordinates are reversed or switched, whichever one you want to say. The graph of f inverse is a reflection of the graph of f with the respect to the line y equals x. Remember we said it's going to go opposite. Okay, so the way we're going to do this is we're going to set up a t-chart. Set this up with me. Does anyone have their calculator with them? Okay, I would open the calculator up. You should probably all have your graphing calculators.
How do you do that?
Okay, so on your calculator, you're going to go to your y equals in the corner. You can see where my mouse is. And you're going to clear. We're going to put in square root of x minus 1. So this is how this needs to work. Second x squared. So the second x squared key is going to give you the square root sign. Remember your x is next to the green button, minus 1. Then we need to close the parenthesis. The square root of x minus 1, close your parenthesis. Now, we're going to go hit second, and then graph, which is going to give you the table. You see that? Okay, now this says error, which means these points don't exist when x is 3, negative 3, because it's a square root function. Remember, square root's only perfect numbers. Wow, where did my calculator go?
It ran away.
So let's pick some numbers that really exist. Do you guys see I have the point 1, comma 0, right? So let's add that to our chart. We have 1, comma 0, so on your T chart that we just made, so I know I have 1, comma 0, and then wasn't there a 5, comma 2? We don't have to do the decimals. Is there a 5, comma 2 on your chart? Look at your T chart.
Yeah.
Or your calculator.
There's a 2 and a 1.
There's a 2, comma 1.
Yeah.
Oh, did I miss it? 2, comma 1, 5, comma 2. And then what's the next one? Is it a big one? 10, comma 3? Okay.
17.4.
Okay, let's just do 10, 3, and then let's stop. So let's graph these points. Graph 1, comma 0. Two, 1. Five, 2. 6, 7, 8, 9, 10. This is a little off scale. 10, 3. So if we want to graph the inverse of this, what do I need to do with my ordered pairs then? What? Flip them, right? So F inverse, I'm going to look at the ordered pairs that I have and I'm going to flip them. I should have 0, comma 1, 1, comma 2, 2, comma 5, and 3, comma 10. Does everyone see where that came from? I took my ordered pairs and I flipped them around because that's how I'm going to get the inverse. So now I want you to graph the 4 points of the inverse. Shouldn't need to be looking at mine. You should just be graphing these points on yours. And notice my line y equals x goes right through this and cuts it in half. You guys see how it splits it and makes it a reflection? That's the line y equals x that every function is the inverse of. Okay, so this problem says find the inverse. Did we do that yet? We found points for the inverse, but did we actually find the inverse of the equation? No, so let's do that. We're not going to do example 6, so if you want to kind of scoot over here and do the function, because we ran out of room. So if my function is the square root of x minus 1, I want you to find the inverse of that function. So you're going to switch x and y. We're going back to that. Switch x and y. Should be getting x squared plus 1 equals f inverse of x. Okay? Any questions about this?
It's not a parabola, how is it squared?
It's half of a parabola. Because, do you see this right here? That's half of a parabola, right? But the square root's only ever going to give us the positive values. So that's why it's only the positive values of the parabola. Good question. Okay, so it says find the domain and range. We're not going to do that. We're going to pause on that. That's going to come later. So for your homework, you have 8 problems where you need to find the inverse and 2 where you need to graph and find the inverse. Okay, so you can use your graphing calculator for that.